There's so much to talk about. I can't possibly fit everything into this one talk, so this isn't even going to be complete, but it'll give you a taste of what's coming. So I should introduce myself. I'm Dave Herman. A lot of my colleagues call me D Herman. That's my GitHub ID, my IRC nick. My Twitter ID is Little Calculus, which is a long story. You don't want to know. And I love JavaScript. I've loved JavaScript for a long time, even when I was a teenager in high school and was completely baffled by it. There's something addicting about it. And I've spent long enough with it that, like Doug, I know not just the good parts, but all of its warts. And I can see the little pearl of a language or gem of a language inside that's struggling to get out. So I love JavaScript for the language that it almost is. So that's why part of my job is to work on the ECMA TC39, which is the exciting name of the standards body that is working on the next version of JavaScript, working on the future of JavaScript. And I represent Mozilla on that committee. Partly I'm here to talk about new powers that we're bringing to JavaScript. There's a couple themes. There's so many features, you have to start grouping them in, thematically. So the first set of features I'll talk about are really about doing things with JavaScript that really you just can't do, or maybe you could do it, but you couldn't possibly do it efficiently enough to work in practice. And one of those things is binary data. There are so many things that you need to do in a full-featured platform that involve reading binary files or communicating with binary network protocols. And JavaScript really doesn't have any good data structures for handling that. So there was some work by the Kronos group on a typed arrays spec, and I've now become co-editor of the typed arrays spec. But we're working on sort of expanding out the kind of convenience and power of what you can even do with typed arrays. So the kinds of things that you can do with our new binary data spec are you can define new binary data types that look a lot like structs from languages like C, except that this isn't a static type system here. What I'm doing is, at runtime, I'm constructing an object that's sort of like a data descriptor. So this point2D here is actually a JavaScript object. It's a JavaScript object that describes the structure of binary data. So in this case, it's a struct with two fields called x and y, both of which are going to be 32-bit unsigned integers. Here's a color type that is a triple of unsigned bytes. So what can you do with that? Well, you can combine those into more struct types. You can mix and match these. You can define your own data types that now describe the structure of compact binary data. So I can describe a pixel as a pair of a point and a color, and I can describe a triangle as a 3-element array of pixels. And I can use that triangle data structure to create, that triangle type to create a new triangle struct. And the cool thing about this is that actually in memory, this is going to be represented compactly. So all that data is going to be laid out in a very compact manner. So even if you're not doing any kind of I/O whatsoever, the binary data spec lets you describe data structures in JavaScript where you actually have control over the exact layout in memory. So that could be nice for efficiency. That could be useful for like cryptographic protocols or algorithms that operate over a lot of data. They're very data intensive, and you'd like to have data locality. But it can also be then used for things like files and network protocols. Okay, so another power that you really don't have in JavaScript right now is the ability to create private properties of an object. And thanks to Doug Crockford, we all know that there is at least a design pattern that we can use. This is sometimes known as the objects as closures design pattern. And Doug really taught the world how to do this. So this actually comes straight off of his tutorial. We have a container class here where we want to have a secret property that's not actually accessible to anyone outside. But maybe we want to have a method that can actually refer to that. And the way that we do that is we create the method inside the lexical scope of that variable. So that works, but there's a real downside to this, which is that every single time you create an instance of container, it's going to get a fresh closure, a new allocation of a new function. There's no way, if we wanted to have one single definition of this service method, to put that on the prototype. If we try to put that on the prototype, it suddenly no longer has access to secret. So it's kind of a rough choice you're stuck with in JavaScript. If I don't care about having private properties, I can put things on prototypes, I get nice sharing. A lot of the JavaScript engines heavily optimize prototype lookup. In fact, all of them heavily optimize prototype lookup. So you get really good performance, you get really good memory usage, but you don't have private properties. So in one of the proposals for the next version of JavaScript, we've introduced the notion of a private name or a private key. So here at the top, I can create this key data structure, which is a special property name that's not a string. So it's not forgeable. You can't guess it. So somebody else who doesn't have access to this key has no way of knowing what the key is. You can decide who to give it to if you want to, but if you want to keep it private, you just keep it to yourself. So now what you do is simply assign to the property based on that key whatever you want, and now you can happily put your methods inside the prototype. So if there's anybody here who's familiar with some of the security patterns that have been catching on the web, like object capabilities, this actually is very similar to that. But it's not just about security. I've found that when I program, the more I leave things just sort of out there in the open, the more I accidentally trip over them. So sometimes it's nice to just hide something, and that way I know that somebody who's not supposed to be even accidentally using it isn't going to trip over it. There's some new data structures that we're introducing. So the weak map, actually, this one I believe is already, it's already shipping in Firefox. I think it's in progress in Chrome. So weak map gives you a kind of hash table where the keys can actually be objects. They're keyed on the identity of the objects, but those keys are held weakly. So you can do things like I just concocted a simple example. Here you might have a tile-based map program like Google Maps or Yahoo Maps. And each one of those tiles might want to be evicted at some point if you're starting to load too many tiles. And at the same time, you might also occasionally have search results that are dropping little markers on top of the tiles. And maybe you don't want those markers to actually be members of the objects themselves. Maybe you want them to be a separate data structure. But you'd still like the lifetime of the markers to be tied to the tiles. So if I have some tile that's way out of view, and I haven't used it in a long time, and I just want to let that tile go, the markers associated with that tile are just as useless. So those should be able to be garbage collected as well. And the cool thing about weak maps is when you have this association, as soon as the key disappears, the value disappears from the table as well. This isn't necessarily something you would use all the time, but it's a power feature, and I think frameworks are going to start finding a lot of interesting uses for this. Another one that I probably don't have time to go into in great detail, but is really cool, and another sort of low-level power feature that I think people are going to do a lot with are what we call proxies. So these are meta-programmable objects. These let you create objects where every single aspect of the semantics of that object, every operation you can do with the object, getting, setting, deleting, etc., is actually under the control of the program. So you can define a callback that handles every possible object event that can happen to this object. So we already have some projects at Mozilla that we're doing with proxies. They've been shipping since Firefox 4, I believe. So one of the things that we're doing is we're trying to re-implement the entire DOM as a pure JavaScript library. But the DOM was designed back in the day where it was assumed that it was going to be written in C++, and so DOM objects have some really strange behavior that don't act like normal JavaScript objects. But proxies give you the power to give your own custom behavior to objects. But proxies can do more than just sort of re-implement the DOM. You can kind of invent your own object semantics. You could do things like invent a new kind of inheritance mechanism. So again, I think this is a low-level feature that might take a while for people to start finding cool uses for, but I think they're going to experiment with it, and they're going to find really amazing things that they can do with them. Okay, so those may look a little abstruse. This one I think is a problem that everyone, I'd be willing to bet that just about everyone in this room deals with this all the time. We all know that JavaScript has this sequential run-to-completion semantics, and anytime we want to do some sort of I/O, we're forced to register a callback that will be invoked later on when the I/O happens. And I like to imagine that sometimes JavaScript programs look like trying to make recipes where every single step in the recipe involves flipping to another page. So if you imagine after you pour a half a cup of water into the pan, you have to go to the next index card. And so, like, how many times have you written a JavaScript program that looks like this? I think the best name I've heard for this is the Pyramid of Doom. So the feature that we're working on to address this is a kind of interruptible function. These are known as generators. If you're a Python programmer, they'll look very familiar to you. They're originally designed actually to be almost exactly like the semantics of Python generators. You could also call them coroutines. There's some slight differences with coroutines. So a generator looks something like this. It's a function with this special star sigil that says, okay, this is a different kind of function. And inside of a generator function, you're actually allowed to use this new keyword yield. And what yield means is I'm actually going to stop the execution of this function here, and I'm going to return to whoever was using the generator and give them whatever argument was passed to yield. But I'm going to save where I was in the middle of the function so that you can resume it later. This is maybe not obvious when you first look at it. So here in this example, we have two yield statements, and it's when the caller calls the next method that we keep resuming. It might not be immediately obvious what you can do with this, but there's actually really powerful idioms you can do when you have the power to stop what you're doing in the middle. So one of the things that I've been experimenting with is a new library called Task.js. Task.js gives you something like a sort of lightweight threading in JavaScript, but with none of the painful locking or anything like that from Java. But what it lets you do is the kinds of I/O that we do in JavaScript all the time, where you can say, I need to stop what I was doing right now, and don't restart me until the event that I'm waiting for has occurred, and then just pick up where I left off. So here you can see I'll do an XML HTTP request and ask for a file, and then stop. I'll call yield, wait for the result to come back in a string, bind that to the text variable, and now I can continue. And I can do a timeout, and I can say wait 1,000 milliseconds and stop, don't resume me till that timeout has happened, and then start me up again. So all of a sudden, there's no more Pyramid of Doom. We're actually writing what looks like sequential code again. But you can still tell that it's a run-to-completion semantics because you never stop what you're doing unless you explicitly say the keyword yield. So this gives you a nice compromise between not having the kinds of preemption semantics you get in a multi-threaded language where at any point anybody could stop you and mess with your program state. It's only when you decide you want to interrupt your program. But it lets you write in a much more natural style. So Task.js is a really fun project. I'm experimenting with different scheduling policies, and I invite you to check it out on GitHub. And if anybody's interested, I'd love to have more collaborators. All right, the next feature is maybe the single most important feature, in my opinion, that's coming in JavaScript, and that is the module system. So in my mind, one of the big motivations for modules is that JavaScript still has a lot of catch up to do in terms of building a huge repository of useful, reusable libraries. We're getting there. Node.js has made great strides. They're using CommonJS. Because of that, they've got the NPM package manager, so you're starting to see already, just with the creation of that one repository, thousands of JavaScript libraries are showing up, but we don't really have the same thing for browser-based JavaScript. We really don't have the great repository of JavaScript libraries. And I think a big part of that is there's friction created by the fact that there's no module system built into the language. There's no one standard way that you can package up your code and ship it to somebody else to reuse. One way of looking at this is when you start up a JavaScript environment, the environment just sort of hands you this really malleable ball of clay. So that's the browser, and that's your empty script tag. And there's a lot you can do with a ball of clay, especially when you have Doug Crockford to teach you all the tips and techniques for sculpting. But sometimes it's nice to just have a little bit of structure come out of the box. So what has Doug taught us? He's taught us the module pattern. And the module pattern works pretty well, and it could be worse, but it's a lot of boilerplate that you have to write just to create a simple module in JavaScript. So this is probably familiar to everybody. The idea of the module pattern is you wrap your code in an immediately invoked function expression, and that way you're guaranteed that you've got a fresh scope, you're not going to pollute the global namespace, and then you represent the result of creating the module as an object whose exports are the properties of the object. So this is doable, but there's a lot of variations on it. There's no standard way of doing it, and you really don't get any help from the language. So as a language nerd, whenever I see design patterns, I think of those as sort of crying out for help from the language. It's programmers saying, this was something that was missing from the language. We figured out a workaround, but we really would have been happier if you had built it in to the language in the first place. There's a quote from Paul Graham that says, whenever I see design patterns, I wonder if these are not evidence of the human compiler at work. As a language nerd, again, I don't like being a compiler. I'd prefer the compiler to be a compiler. So the module system in ECMAScript.next just lets you say exactly what you meant. You can define a module, you can give it a name, and you can say what the exports are simply by labeling them as exports. There's actually a lot more to it, and I have done entire talks just about the module system. One of the really nice new powers of this module system is that you no longer have to use the script tag to get external files. So when you import some of the exports from a module that came from an external file, the semantics guarantees that this is loaded once, so you can import from the same file multiple times and it'll only be invoked once. And notice that it's doing I/O, but we don't have the pyramid of doom. So it's actually doing all of the loading before execution starts, so there's no danger that your code just starts blocking arbitrarily in the middle. Okay, so another theme of JavaScript of the next version of JavaScript is features that add expressiveness to the language. And one way of thinking about expressiveness is it's about helping with the problem of the death of 1,000 cuts. There's all the little paper cuts that we suffer through every day as we're writing JavaScript code. The fact that the arguments array is not actually an array, so we can't use any of the array methods on it. The hoisting of var, the function scoping that Doug talked about this morning, type of null, that's just kind of weird. So we're just adding a lot of new conveniences to the language that probably should have been there in the first place. Instead of having this arguments variable that you can refer to that has the entire array of arguments, well, sometimes you only wanted the rest of the arguments, but you want to name some of the other ones. And the simple syntax of 3 dots followed by a variable name just lets you do exactly that. You can bind the remaining arguments, and this time it'll be a real array. You can actually use all of the array methods on it. And furthermore, you can actually use the ... syntax to splice in actual arguments when you do a function call or when you do when you call a constructor. For the language lawyers out there, this bottom one actually was impossible to express in ES3, and there's one little detail of ES5 that accidentally gave you the power to express this, and that's function.prototype.bind. Anyway, another one is default arguments, default values for optional arguments. This one's just, you can write it, but it's a pain to write it, and you'd really rather just be able to write it like this. So we'll just have that work out of the box. This one, again, Doug talked about this morning, the let construct as opposed to var. So you can just think let is the new var. Anywhere you would have used var in the past, replace it with let, and chances are your program's going to work better. Unless, of course, if you always followed Croc's rules and you put your vars at the top of the functions, your program's going to act exactly the same. But now you can actually bind things in a local block and get the semantics that you expect. Destructuring. This one is in a lot of other languages, but for people who haven't seen it, it looks kind of surprising at first. And then once you start using it, you wonder how you ever lived without it. This saves you so much typing. So here we have thing.color as an object that has R, G, and B properties. And instead of having to write 3 statements that say var R equals thing.color.R, var G equals thing.color.G, we get to just automatically unpack the contents of that object in one single operation. Same thing with arrays. This makes it nicer to write functions that just return tuples, and you can just unpack them in one go. You can also use it for cute idioms like swapping. So here, without actually naming a temporary variable, you can swap the variables A and B. And anywhere you do a variable binding or a variable initialization, you can use destructuring. Whew, OK, how are we doing? We've got a lot of new conveniences for object literals. So the first line is the syntax everyone's familiar, or the first line inside the object is syntax everyone's familiar with. But the second one is just a convenience for defining methods. So you don't have to write function. You can just write the name, the parens and the arguments, and the body. This is something, to this day, I accidentally type it without even thinking. It's just sort of my fingers have always wished that feature were there, and now it will be there. And then the third one is really nice. This is something that you can't do without doing an extra assignment outside of the object literal. You can actually dynamically compute the name of a property. That'll also be useful for private names. So you can define a private key outside, and then you can, inside the declarative object literal, you can refer to that key. All right, just a few more. Everybody knows that for-in only does what you want about half the time. It's got all sorts of problems with prototype leaks, and one of the most common bugs is people do a for-in loop over an array, expecting to get the elements of the array, and instead they get the indices of the array. Originally, we were thinking about actually extending the for-in loop and sort of reforming it. But most people felt that that was going to be too deep of a change to the language. It was going to be too difficult to migrate existing code. So we introduced a new syntax, the for-of loop. So a mnemonic you can think of is the keys are in the object and the values are of the object. So if you do a for-of loop over an array, you'll get the values. That's what you expect. In fact, if you do the for-of loop over any object, you're going to get the values instead of the keys of the object. But we'll also give you some sort of batteries included, some built-in functions that let you describe custom arrays that you want to iterate over, or custom sequences you want to iterate over. So you can say for x of the keys, for x of the values, for k and v of the items. So that'll be a sequence of pairs. This code is just a little bit easier to communicate exactly what your intent was, where for-in is pretty hard to unpack. And in fact, the for-of loop we're going to make extensible. So you can define your own custom sequences by defining what's called an iterator object. So if you add the iterate property to any object, and this is going to be a special shared name object, iterate, instead of polluting the public namespace. You can create your own custom iterator object, and now you can do a for-of loop over that object with whatever custom behavior you want. Once you have custom sequences, then it's really nice to add sort of syntactic sugar or syntactic convenience for what are known as comprehensions in languages like Python and Haskell. So here we're very concisely describing an array whose elements are x times y for each value x of object 1 and for each value y of object 2. And this syntax actually goes back to math. This comes from the set comprehension syntax in math, but it turns out that it's pretty easy to give it a straightforward semantics in a programming language, and it turns out to be really concise and convenient to use. Okay, tangled up in strings. So much of web programming involves hacking on strings. We're embedding fragments of HTML. We're embedding fragments of various kinds of languages, and all you get in JavaScript, the only syntax you get in JavaScript is string literals and plus. This is obviously a pain. I think that Doug has left, so he won't hear what I'm about to tell you. We will give you multi-line string literals. There's no backslash at the end of the line. You just write it as long as you want. If you don't mind the indentation thing like he does, this will just work as you expect, but without the hazards of white space following the backslash. Notice that this is using backticks instead of the normal string. But we also have string interpolation like you get in so many other languages, in shell scripting and PHP and Perl. This is a very often requested feature in JavaScript, and it just makes it so much nicer to read the code. But we're actually going to take it one further. There's an optional prefix that you can add to one of these literals. And what that prefix actually does is it basically says you can refer to any function here, and this function is going to get the contents of this string sort of nicely organized into the literal parts and the interpolated parts, and you can write your own sanitizers. So it makes it really, really easy to write sanitizers for things like HTML to prevent injection attacks. So in addition to getting some of the convenience of nicer string literals, you also get a very convenient way of writing security-conscious code. Okay, so that was sort of my whirlwind tour of a lot of the features. It's not, by no stretch is it all of the features that we're considering, and I'm happy to answer any questions if people have been following on ES Discuss or on the web. But I just want to address the number one question that we always get, which is, well, that all sounds fine, but it takes years for these things to roll out. How long do I have to wait before this is actually in the hands of enough of my users that I can really use these features? And that's a fair question. And here are my answers. First of all, it's our job on this committee to work as fast as we can to get this stuff out as soon as we can. So the next edition of the spec is targeted for 2013, which is coming sooner than you might think. But as vendors, like at Mozilla, we don't have to wait for the spec to be finalized before we start shipping features. So, for example, proxies and weak maps are features that are fairly stable in the spec, and we've already shipped preliminary versions of them in the browsers. It's always a guessing game to know exactly, what might be more likely to change by the time the spec comes out, but this is just, it's important to remember that the due date for the spec is not the same as the date at which the features are getting in the hands of users. That said, we're still talking about bleeding edge browsers. We still have a laggy market. So I think there's one other approach that, there's an approach that I'm hoping will help. And we're starting to work on this. Brendan Eich has talked about this in several of his recent talks. And this is the idea of a transpiler. So transpiler is just a kind of compiler that goes from sort of a high-level language to another high-level language, or that does a very lightweight compilation. CoffeeScript is the canonical example. Google already has a transpiler for what they'd like to see as the next version of ECMAScript. It's not exactly what's in the spec, and the spec is still ongoing. We also have a JavaScript in JavaScript implementation called Narcissus, and we're working on doing a language shim ourselves, just as an experiment. But it's my hope that we can actually get to a point where, just like doing CoffeeScript development, you could write in the new version of the language, but then compile it down to a more backwards compatible, web compatible version of ECMAScript. So what we're hoping is this will let people start using the language before it's actually shipping in the browsers. And as a stopgap, they can compile down to the version of ECMAScript that is in the browsers, but in time, when there's native support for more and more of the features, they can use less and less of that compilation and get better performance and possibly a better debugging experience. Okay, so that's our little tour of the future of JavaScript. I'm happy to take as many questions as people have, and I'll try to stick around a little bit, but then I will have to rush off back to my master's, back in the room full of futuristic language nerds. So thanks very much for your time and attention. So the question is, are there any features from the old version that have been removed? This is a subtle question, because in one sense you can't ever remove anything from the web, or there's very little that you can remove. But the new version of the language is going to have an opt-in language type. So you'll actually be opting into the new version, and that means we do have some flexibility to break some compatibility and remove some features. So we are doing that. In fact, even ECMAScript 5 strict mode already did that. So for example, the with statement is kaput, it's gone. We will do a little bit of removal, but we want to keep the migration cost as low as possible. We want people to be able to take their existing code and start moving it into the new version of ECMAScript. So we're going to be very careful about what we remove. That's a very astute comment. The way that you create the struct types is assuming that they're in order. And the answer to that is, in practice on the web, if you have alphabetically named properties, they actually are ordered. So for now, we've been going with this because it's the nicest syntax. But if we can't actually nail down the semantics of some amount of property order, we'll be forced to make a more verbose syntax. It's my hope that we can have this nice, pretty syntax, but we'll have to. That's still an open question. We have to nail that down. So is the question, what's the future of classes and inheritance in JavaScript? Yeah, that's one that's conspicuously missing on my slides. It's one of the more controversial pieces, and we've started working really in earnest on classes fairly late in the cycle. So there's still a lot of discussion going on. In fact, that's the topic of this morning that I'm missing right now is classes. We've come to a lot of agreement about a lot of pieces, and we've talked a lot with the community, and most people say, I don't want anything that even smells remotely of Java. That is the message we hear loud and clear. But what we're talking about when we talk about classes is something much more like CoffeeScript. It's a nice syntax that gives you a convenient way of expressing the patterns that people already use in JavaScript. So it's a constructor function that has a prototype object, and it would be totally interoperable with existing constructor functions with prototype objects. This turns out to be one of the ones where the semantics is not really the hard part. We know the semantics should be do what JavaScript already does. The syntax is just really tricky. So this is a sort of like UI design. It's getting the layout of the syntax just right is really tough. But we're working on it, and it is still, I mean, it hasn't been cut from the set of features, but the discussions are still ongoing. The question is Microsoft on board with this? Microsoft works actively on the committee, and only they could tell you what their company strategy is. There's no way that I don't have a divination rod here. I can't guess. Great question. So the question is, can an existing object be turned into a proxy? The current proxy spec only lets you create a new proxy from whole cloth. It doesn't let you go around and muck with the sort of meta semantics or the underlying behavior of an existing object. There's a lot of things, though, that would be really nice to be able to do, like you already can add getters and setters to an existing object. It would be nice if you could add proxyable behavior to existing objects. Proxies are something that hook in at the very lowest level of the language semantics, and so it's a very delicate thing to design each piece. We are having ongoing discussions about which parts of the proxy API would make sense to let you add to an existing object. There's a good chance that that won't be ready in time for the next version of the language. But one use case that Microsoft actually brought up on the committee was if you want to do data binding. So if you want to have objects that you can listen in on changes that happen to them, you don't want to have to force them to have created them as proxies in the first place. You'd like to be able to take some existing object and say, hey, I want to listen in on these different events. So there are definitely strong use cases for being able to add proxy behavior to existing objects, but the first version of the API doesn't let you do that. Okay, I don't want to keep anybody from lunch, so thank you very much.